Hello friends, good morning. I am Rajiv Ranjan, a student of Amtech CSE from Bennett University, and here I am going to present my project, that is vehicle detection and its speed tracking from videos. So this project will help in many ways to make traffic system quite good. So let's move to the introduction. So vehicle detection and its speed tracking from the videos is an integral part of intelligent transportation systems. So it can provide remotely surveillances of the road and highways to detect the motion of the different vehicles and their activities. And the next is it will also help us to record the traffic condition over different parts of area in cities and on highways. So definitely monitoring the situations of the vehicles and the rush in different part of road is quite good thing. The next is it will make coverage of the whole traffic management system. So it will also help in managing the traffic systems by sitting anywhere in the control room. The next is we can track the speed of moving vehicle from videos. So here from this part of project we can track the speed of any vehicle from video surveillances only, so that it can enforce some speed limit laws to prevent lots of accidents from over speeding, right? So to deploy this project there are some requirements, software requirements and hardware requirements as well. So we can see here, like we use OpenCV for vehicle detection and speed tracking. So OpenCV is just an open source library for image processing, and it is very nice for detecting objects. So the thing we have to do is to just import the OpenCV library in our Python program. So there is a simple program in Python with OpenCV libraries for vehicle detections. So for vehicle speed tracking we will do real-time tracking, so that the whole system can install anywhere. So the best part of this project is this, so that we can install it anywhere, right? And it is very easy to install. So some of the requirements of program runnable are like we have to install Python 2.7 in our computer, and the next is we have to import OpenCV 2 version library in Python program, and there should be proper running of NumPy in Python. So these are some software requirements, and there are some hardware requirements, like Raspberry Pi 3 model, which has very nice processing power. So we have used Raspberry Pi because it's a small processing unit. We can take it anywhere and installed at any place very easily. So we have to just install Python and OpenCV and NumPy, proper running NumPy on this Raspberry Pi unit, and we can run that program. And to capturing the image we'll need PyCam or any USB cam, so that it can capture the image. The last thing is Raspbian. I have mentioned here the Raspbian is nothing, just an operating system for Raspberry Pi 3 models, on which we can see everything in the free UI form, the user interface, right? The next move forward, that is the methodology, the basic idea behind this concept, that how we'll calculate the moving speed of the vehicle. So the basic idea is just we'll put two imaginary line, the two constant figure on the road, and mention that distance in our programs. Now we will calculate the time when the front of the car will just enter the first imaginary line, and also record the exit time of the front of that particular car. So by calculating the first instant of time and the second instant of time, and going through this formula, that is speed equals to distance upon time, we'll get the proper speed of that vehicle. So this is the basic idea, and here's the algorithm. So how that basic idea is implemented, so we can see here again from this diagram. so that there is a two imaginary line, like this is the first imaginary line and this is the second imaginary line, right? And here y1 and y2 is the coordinate of that two imaginary line, and t1 and ti and te is the time instant of the both respective imaginary line, right? And we can see that the meeting point of the first imaginary line with the front view of the vehicle, so that we mentioned the coordinates points here, that is xti and yti, and again for the second imaginary line same, the coordinate will be yte and xte, right? So while going through this algorithm, we have to compute this formula, that is v equals to del y upon del x equals to yte minus yti upon te minus ti. So after getting all these value and computation it through our Python programming program, we will get the velocity of that vehicle, right? So here is the result. Once we run our Python script, that is carspeed.py on terminal, it will pop up a speed tracking window like this wherever we have installed our whole system, right? So this is the scenario of the roadside of the Bennett University. So the first thing we have to do is to just create a monitoring zone by dragging the mouse over this window and press C. So after pressing C, it will generate two imaginary line on the roadside, so that will be the entering and exit point of the vehicle from the either side. So now we have to wait to just get the vehicle in here, so it will calculate the speed of that vehicle. So before that, we can see here in the Python shell that there is no car detected, right? And here it has mentioned that 27 feet is the distance from the 27 is the distance from the road to the camera, and these are the coordinate of the monitoring zone, right? And we can see the time on which vehicle has covered this the monitored zone, and the speed in mile per hour and the other values. So right now there is no car detected. So once the car will move inside this monitoring zone, so we can see this, like the Python shell will certainly pop up the message that car is detected, right? So here we can see that car is detected now with a speed of 35 mile per hour. So the speed of that particular vehicle will indicate at the caption of that image. So one more thing we have to explore it here, that we can see the different plants and trees which can be moving, right? So that can be a disturbing part for the camera and for this program as well. Therefore I have put a threshold value like 5 or 10 mile per hour, so that it will only detect the motion of that object which are moving above the threshold value, means above the speed of 5 or 10 mile per hour, so that it will only detect that part of the object, the motion of that object. So on the basis of that idea, we can get the speed of this vehicle here, right? And one another thing that is very important, that is the distance. We have to mention the distance for the from the camera lens to the middle of the road. So once we changing the location of this project, we have to change the value of distance every time in the Python program. So according to these, we can run this project and get the speed of the vehicle. And we can observe it or monitor it through any part. Means, we can get these videos or result from the IP address, so that the Raspberry Pi model is installed anywhere and we can monitor by sitting at other places, right? Let's proceed. So the next thing is some challenges. So there are some challenges and limitations of this project. So the first is dynamic state of vehicles. So detecting different kinds of vehicle and their state is a quite difficult thing. The next is weather condition. Weather conditions disturb the pattern of this program, because it depends on the quality of the camera, so that we can capture the speed of the vehicle at night also, at rainy season also. The next is other moving objects as an obstacle. So we have resolved it somewhere by putting threshold value. The next is variance in lane changing by the vehicle. So it will only work for the single lane vehicle. So collapsing or get together with other lane will disturb the working pattern of this project. And the very important is camera calibration. Once we change the angle of the camera, we have to change the various values in our program according to that calibration of the camera. So we have to take care of that. And still the programming is very complex to detect the speed of the vehicles. So there are almost 200 lines of code to do these projects. So the programming is quite complex. So we'll go through it and work more, so that we come over these limitations, right? And that's it. Thank you.